In this section, we will talk about functions. And functions play a crucial role in functional programming. We are using them as the basic blocks to structure and to generalize our code. In Reason, you can use a function like any other value. It can be, for example, passed as an argument to a function, or it can be returned by it. And we can use functions to create expressions by applying them. And in order to do that, first we need to know the type of our function. Let's write an example. We have our first function. As you can see, functions are declared with an arrow and they return the expression. And this is very similar to arrow functions in JavaScript, for example. In our example, we declared a function and assigned it the name getInt. The type of a function is composed of its argument and its resulting value. So the getInt function is recognized as a function of type int arrow int, which means it takes an integer as an argument and returns another integer. Reason's compiler again inferred the type for us. It saw the plus operator inside the body of the function and it figured it out, that the argument as well as the result must be an integer. For longer functions, you would surround the body with a block using curly braces, like this. Now, let's create an expression by calling our getInt function. We got back our integer expression 13. Let's write a function that expects several arguments. Now, to apply a function with several arguments, we just write the name of the function, followed by the different expressions which calculate the values of the arguments. Again, the type of our function is written as a sequence of all the argument types and the result type at the end. In our case, our function takes two integers as arguments and return another integer as a result. Now, let's call our function. And we got back integer 10. We can also write at the position of the actual argument any expression which computes a value of the expected type. As you can see, the first and the second argument might be more complex expressions which are to be evaluated before they are passed as values to the function. What if we call our function with just a single argument? Well, let's try that. As you can see, we didn't get any error, since functions in Reason may be undersupplied with arguments. However, you will get a result of a different type that you might expect. In our case, we got back a new function waiting for another integer argument to be passed, since the original addInts function expects two integer arguments and we passed only one so far. And this is called currying, and it means that if you won't pass all the arguments to your function at once, you will get back a new function waiting for the rest of the arguments. Now let's verify this in our example. We called addInts function with the first argument. We got back a new function waiting for the second argument and bound this function to an identifier called curried. Then we called our new function with an integer and we got back 13, the result of the original addInts function. So undersupplying functions with arguments is no problem in Reason. However, what if we oversupply our function with arguments? Let's try that. We got an error since the add-ins function is defined as a function expecting only 2 arguments, and we passed 3 of them. So Reason is telling us that we tried to apply too many arguments to our function. At the beginning, we've mentioned that in Reason we can pass functions as arguments to other functions. Let's try to do that in our example. We passed an integer as the first argument. However, as the second argument to the add-ins function, we passed the result of another call of add-ins function. And this is called functional composition, since we are composing several functions together. And we will talk about currying and functional composition more in the future sections. Reason, as almost all modern programming languages, is governed by the principle of lexical scoping. Let's take a look at what lexical scoping is. We will define 3 functions. The first function, f1, takes an integer and adds 1 to it. The second function, f2, takes an integer and calls the first function f1 in its body and adds the result to the integer. The third function, called again f1, takes an integer and adds 10 to it. So, we created 2 definitions of the function f1, and we also use this function in the body of the f2 function. This f1 function inside the f2's body is the one which has been visible at the moment when the f2 was defined. In other words, this is the version of the f1 function that was defined initially, and not the one which was defined lastly. It doesn't matter that the application of f2 function comes after the second definition of function 1. And this is what the lexical scoping is. Let's verify that by calling our f2 function. When we call f2, the first version of f1 is called inside the body of the f2 function. The f1 returns 3, and then we add our argument 3 to it, and the result is 6. More generally, lexical scoping is if you write the definition of a function and you use it in the body of another function, then it always refers to the identifier which was visible at the moment of declaration of the function, and not to the one which was visible at the moment of execution of the function. That would be the opposite principle of dynamic scoping. So, one last recap. For lexical scoping, it's the identifier visible at the moment of function definition, while for dynamic scoping, it's the identifier visible at the moment of function invocation. In Reason, you can give several definitions of identifiers using the same name. When you do that, you just give a new definition of a new identifier which might locally shadow a previous definition. But don't confuse this with the changing of the value of a variable, as you have, for example, in JavaScript. Lexical scoping, we've just talked about, can give you indirect access to an otherwise hidden identifier. Let's take a look at the example. We have an identifier x with a value of 5. Then we have a function that expects an integer, adds the value of x to it, and returns the result. Then we call the function, and we also define a new identifier, x, with the value of 60. Finally, we are calling our function again. Now, the second x identifier is the new one, and is not visible at all by the function func, which has been defined before. So, when we call the function func, the x identifier inside its body always refers to the first definition of the x identifier. One last thing about functions. Keep in mind that functions are normal values in Reason, just like, for example, integers or strings. Let's write an example. This is valid code. However, since this function does nothing more than apply another function with the same argument, we can also write it just by assigning the existing function to a new identifier, like this. As you can see, this is more concise than the first version.